Good morning, my dear children. Once again, your Lalitha ma'am is back with another topic. The series of IIIT Basara competitive exams are going on. Okay, so in that context, we are uploading chemistry chapters of class 10. Okay, so most of the questions, model questions and all also we will be discussing. Each chapter we are dividing into 3 parts. In part 1 and 2 we are discussing the concept overview, and then in part 3 what type of questioning will be coming. Okay, so in today's topic, in today's video, we are going to learn about what? The second chapter of 10th class portion, that is acids, bases and salts. Okay, now acids, bases and salts. Okay, this is a very important topic in the examination point of view. So many questions you can expect from this lesson. Okay, and different way of questioning, okay, you can expect from this lesson. So this is a lesson of very big weightage, okay, in competitive exam point of view also. Okay, so let us without any delay, let us go into the topic of acids, bases and salts. Okay, so in this video we will be doing only part 1 up to properties of acids and bases. Okay, that up to there we will be learning. The next part of the lesson about salts and about pH of salts and all, we will be dealing in the next coming video. Okay, but properties are very much important, my dear children. So you have to focus on all the properties which are being exhibited by acids and bases. Okay, so let us recall what are acids. According to the definition of acid, the word acid stands for what? Acidus, which means sour in taste. Okay, so acids are sour in taste. Okay, and they are turning blue litmus paper to red litmus paper. I think you all have an idea about litmus papers. Litmus papers are the substances, the papers which are made from the synthetic dyes. Okay, now from which is taken out from what? Lichens. Okay, so acids are the substances which turns blue litmus paper to red, which are sour in taste. Okay, which are sour in taste and which have H plus ions. Okay, now which have H plus ions, which can have hydrogen ions. H plus ions means what? Hydrogen ions. Okay, and which can turn blue litmus paper to red litmus, blue litmus to red litmus. Such kind of substances are generally termed as what? Acids. Okay, and you have other properties are also being exhibited by acids. These are the general physical properties that are being exhibited by acids, and most of the acids we see generally they are colorless. Okay, now colorless acids. Okay, not much color is being observed. Even if it is observed also, pale yellow color we can observe. Okay, right? So these are the general properties of what? Acids. Okay, and what are bases? Bases are the substances which are soapy to touch or slippery in nature. Okay, now soapy to touch. Okay, and slippery in nature. Soapy or slippery, anything same only. Soapy to touch or slippery to touch, you can say anything. Okay, and they turn what? They have, as bases have OH minus ions present in them. OH minus ions means what? Hydroxyl ions. Okay, H plus ions means hydrogen ions, and OH minus ions means what? Hydroxyl ions. Okay, OH minus ions will be there. They are termed as bases. They turn red litmus to blue. Okay, now they turn red litmus to blue. These are the general properties that are exhibited by bases. Okay, and bases are also colorless substances. Okay, or most of the bases they will be exhibited, they are appearing in their physical state, they are solids. Okay, now solids or powdered state. Okay, or some of the bases like sodium hydroxide and all, they will be appearing in the form of small pellets. Okay, now sodium hydroxide pellets. Okay, so they are solids. Okay, solids. or amorphous powders. Okay, so like this, these are the general properties and physical properties that are being exhibited by bases, right? So if you just go for the chemical properties, before we actually go for the chemical properties, we should learn certain examples and examples for acids and bases, and in our daily life also we will be using certain acids in our daily life as well. Okay, so examples for what? Examples for acids, if you go for, okay, you have different types of acids like mineral acids. Most of the mineral acids, as just now I told, they have H plus ions will be there in them. Okay, mineral acids like HCl, hydrochloric acid, okay, H2SO4, sulfuric acid, H3PO4, phosphoric acid, okay, and you have HNO3, nitric acid. Okay, like this, these all are called mineral acids. They have H plus ion is there as common ion. Okay, and you have second type of acids which are called as what? Carboxylic acids. Okay, now carboxylic acids, that means in these carboxylic acids, these are considered to be organic acids. Okay, now organic acids which has COOH is there as a functional group. Organic acids, okay, where COOH is there as a functional group for that organic compound. Okay, if COOH is there as functional group, they are called as what? Carboxylic acids. Like you can take the example of formic acid. Okay, now formic acid. Okay, examples of organic acids are what? Formic acid, HCOOH, HCOOH, and you have acetic acid is there, which is, in other words, you call it as vinegar. Okay, now acetic acid, CH3COOH, which in other words you can even call it as ethanoic acid. Okay, acetic acid will be there, and you have some other solids, acids in which COOH is there as functional group in them. Like you can take C2H5COOH, propanoic acid, you call it as. Okay, now propanoic acid. Okay, so like that you have organic acids are also available for us. Okay, and acids which are generally found in daily life examples, acids in daily life. Okay, some of the acids we observe even in fruits as well as in vegetables also. Okay, like in fruits, if you go for like oranges, in oranges you have oxalic acid is there. Oxalic acid, this is also an organic acid. Okay, dioic acid you call it as COOH or H2C2O4. It's a formula for oxalic acid. Of course, here they may not ask you for the formulas. Okay, oxalic acid, and then is present in what? Oranges. If you go for vitamin C is called as what? Ascorbic acid. Okay, now ascorbic acid, which is generally present in amla or gooseberry. You all know amla or gooseberry. Okay, in gooseberry ascorbic acid is present, and same like that you have even in tomatoes also, not only oranges, even in tomatoes also you find oxalic acid will be there, and in apples you will find malic acid. Apples you will find malic acid or malonic acid you will find in apples. Okay, and like that you have lot many examples will be there where you will be finding even in grapes also, as well as citrus fruits, lemon fruit, citrus acid, citrus fruits we call. Okay, in all the citrus fruits we find one or the other acidic substances. That's why even they are sour in taste also. Okay, because of the presence of acid present in them, they will be sour in taste. Okay, so these are the general examples for acids. Okay, same like that. If you go for examples for bases, okay, examples for bases. So bases will have in common OH minus ions will be there. You can take example of NaOH. Okay, NaOH, sodium hydroxide. Okay, KOH, potassium hydroxide. Okay, and these two are considered to be the main ingredients in the manufacture of soap. Okay, now soap. You know soap. Soap, in the name itself it is there, sodium and potassium. See here, SO for sodium. Actually sodium symbol is Na, but soap consists of what? Soap is sodium and potassium salts of fatty acids. Okay, so that's why soap, it's named as soaps. SO stands for sodium hydroxide and P stands for potassium hydroxide. Sodium and potassium salts of fatty acids. Okay, that's why the main ingredients of soap are what? Sodium hydroxide and potassium hydroxide. Okay, so general in daily life example also you are finding these substances which are in use. Okay, and next you have lot many examples like MgOH taken twice, which is, in other words, you call it as magnesium hydroxide, chemical name, and you have the another name for this substance which is called as what? Milk of magnesia. Okay, which is generally used as an antacid substance. Okay, now antacid means what? Anti-acid. Antacid substance means which is used for treating acidity which is produced in our stomach. Okay, now sometimes we get acidity. Okay, so in order to get rid of that acidity or burning sensation which causes in our stomach, okay, we use milk of magnesium. Okay, and even gelusil and digene, such kind of syrups which we use as antacids. Okay, that consists of what? Milk of magnesia. Okay, so antacids. Okay, so magnesium hydroxide is there in antacids. Okay, and even you can take sodium hydrogen carbonate, which is called as what? Sodium bicarbonate. Okay, which in other words you call it as baking soda. Okay, baking soda is an example of a mild base which can be treated as antacid. Okay, so like that even in our daily life also we are using lot many substances which are basic in nature. That's why there is lot much to study about acids, bases and salts also. Okay, so let us go for the chemical properties that are being exhibited by acids and bases. But actually before we actually go into the chemical properties, we have to learn about indicator substances. First let us learn about indicators and then we go for the chemical properties of acids and bases. So let us learn what are indicators. Indicators are the substances which are used to identify whether a given substance to you is acidic or basic. Okay, in the name itself it is there, indicator. It indicates whether the given substance is acidic or basic. Okay, so you have three types of indicators are there. Okay, now three types of indicators are there, which are, first type are what? Natural indicators. Second type are synthetic indicators, and third type are olfactory indicators. Okay, olfactory indicators. Okay, mainly three types are there: natural indicators, synthetic indicators and olfactory indicators. So if you go for natural indicators, so in the name itself it is there, natural indicators are the indicators which are obtained from natural resources. Okay, like you can take first and best example is litmus. Litmus papers are obtained from lichens. Okay, now you all have learnt about lichens in biology. Okay, lichens are the symbiotic plants, okay, from which you can extract litmus solution or litmus papers. You can prepare from a thallophytic symbiotic plant which are called as what? Lichens. Okay, so litmus papers, and these litmus papers you have two types will be there, red and blue litmus papers. You all know about this. You were learning about this from class 7 itself, isn't it? So red litmus papers, so if you take acids, Acids, as just now I told, turn blue litmus to red. If anything turns red, it is dangerous, isn't it? Acids, of course, they are not dangerous until and unless we take concentrated acids, okay? Because acids are present even in our body also, even in our mouth also. In our mouth, saliva is there, okay? Saliva is acidic in nature, okay? The milk, every day which we drink milk consists of lactic acid. Curd consists of butyric acid, okay? Rancid butter, sour butter consists of what? Butyric acid. Like that, you have lot many acids are present in our eatables also, okay? So acids, actually they are not dangerous, okay? But for remembrance sake, you just remember turns blue litmus to red, okay? Now blue litmus to red, and bases turn red litmus to blue, okay? Bases turn red litmus to blue. This is about litmus papers which we have learnt in our lower classes, okay? So second type of natural indicators, you have to remember natural indicators. Second example is turmeric, okay? Now turmeric is an example for natural indicator, okay? So turmeric, actually you all know that it is yellow in color, okay? The turmeric root, you call it as what? It will be yellow in color, okay? So if you make a turmeric paper, means what? If you make a paste of turmeric powder and apply that paste over a what we call on a paper, you apply it on a paper, okay? Then test that paper, turmeric paper, with acidic and basic solutions, okay? So if you take turmeric paper will be what? Yellow in color. Turmeric paper plus acidic substance, okay? There will not be any change, okay? No change in the color. Turmeric paper actually will be in which color? I said yellow, okay? But by adding any acidic substance on that turmeric paper, no change, okay? No color change you will observe, okay? So turmeric is there as an indicator, but still with acidic substances it will not change any color, okay? Same like that, if you take the same turmeric paper, okay, same turmeric paper, and apply a basic solution on it, basic solution, like you can take soap solution, okay? Soap solution, or you can take a shampoo. Shampoo is also consist of what? Basic solution only. As I already told you, sodium and potassium hydroxides will be there in basic substances, even in soaps and detergents also, okay? So turmeric paper plus basic solution if you take, okay, then immediately it turns to red. If it turns to red, then you can say that the substance which you have taken is basic, okay? Now the substance, if that substance which turns turmeric paper into red color, then the substance taken is basic substance, okay? You can identify like that. So second type of natural indicator is what? Turmeric. And then third example for natural indicators, okay? Example 3, okay? Example 3, flowers of hydrangea and petunia, geranium, these are the certain flowering plants, okay? Flowering plants, flowers of hydrangea, okay? Now hydrangea, petunia and geranium, these are also natural indicator substances, okay? They change, the color of the flowers will keep changing with the change in the acidic or basic nature of the soil in which these plants are planted, okay? Please understand the point carefully, it's very peculiar for us, okay? For that plant itself, initially this hydrangea flowers will be pink in color, okay? But with the change in the acidic nature of soil, or with the change in the basic nature of soil, that means nature of the soil, if it is going to change, color of these flowers also will be changing. That means what? If the color of the hydrangea, petunia and geranium. If the colors of these substances, these flowers, if you observe them to be changed, okay, then you can say that the nature of the soil in which these plants are planted, okay, nature of the soil also gets changed. Okay, actually speaking, soil is acidic in nature because soil consists of what? Yes, silicon dioxide will be there. Silicon dioxide is acidic in nature. Okay, so according to the pH value of the soil, okay, you will be learning what is pH value. According to the pH value of the soil, okay, the color of these flowering plants, the color of these flowers will keep changing. So they are also an example for natural indicators. Okay, so next you have hibiscus. Okay, na China rose you call it as China rose. Okay, China rose. Okay, so China rose is like hibiscus only. Okay, so for that, if you make an extract of China rose, okay, and if you are going to test that substances, acidic or basic substances, then what kind of color changes you will observe? Okay, then if you take acid substance and add China rose extract, means hibiscus extract, China rose extract, if you are adding to acidic substance, okay, then that acidic substance turns to magenta color, means it is like a violetish pink colored substance, like potassium permanganate color. Okay, magenta color. If it turns to magenta color, then you can say that the substance which you have taken is what? Acid. Same like that if you test it with base. Okay, China rose plus base, China rose extract plus base, it turns to green color. If the substance turns to green color, you can say that the substance which you have taken is basic in nature. Okay, so China rose is also an example for natural indicator. Okay, and next you have beetroot extract is there. Beetroot. Okay, now beetroot extract. You will have wide varieties of color changes based on the strength of the acids also. You will have different colorations can be observed with beetroot extract. And at the same time you have another natural indicator which you call it as universal solution. Okay, now so this actually it is not natural, all synthetic universal indicator you call it as. All synthetic indicators if you mix, you will get universal indicator. But beetroot is, of course, you all know that it's a what we call natural indicator. And finally you have what? Red cabbage extract. Okay, red cabbage extract. So you can remember the color changes in the form of Vibgyor colors. Okay, if the substance which is taken, to which this red cabbage extract is added, if it turns to VIB colors, then it is basic in nature. Okay, na VIB colors are for bases, G is for neutral, YOR colors are for acids. Vibgyor colors you all know. These all are what? Rainbow colors. Okay, so violet, indigo, blue. If any substance with red cabbage extract, if any substance turns to these three colors, okay, now shades of these three colors, then the substances are basic in nature. If they give YOR colors, the substances are acidic in nature. And if they give greenish shade, the substance is said to be neutral. With what? With red cabbage extract. Okay, so red cabbage extract is also a best natural indicator. Okay, so these all are about natural indicators. And second type, you are going to learn about what? Synthetic indicators. We will be learning only two examples in this. Synthetic indicators. Okay, now which means which are prepared in the laboratories. So you have two types of synthetic indicators which we will be learning in this lesson. The first one is what? Methyl orange. And the second one is phenolphthalein. Okay, now methyl orange and phenolphthalein. These two are what? Synthetic indicators. Okay, so you all have learnt even these two, about these two also you have learnt in your lower classes. Okay, like you can say methyl orange will be actually orange in color, and phenolphthalein is actually colorless. Okay, so you have to observe the color changes now with these indicators with acids and bases. So you just remember acid plus methyl orange. Actually methyl orange color is what? Orange. Acid plus methyl orange, it turns to red. If it turns to red, then you can say that the substance taken is acidic. Okay, same like that, base plus methyl orange. Okay, now base plus methyl orange, it turns to yellow. If it turns to yellow, you can say that the substance taken is basic in nature. So with methyl orange, okay, with methyl orange you can observe these color changes. Same like that with phenolphthalein. Okay, acid is colorless, phenolphthalein is colorless, and it remains colorless if you add both of them also. Okay, now with the phenolphthalein, see here, acid plus phenolphthalein. Phenolphthalein is actually what? Colorless. Okay, now acid plus phenolphthalein remains colorless. Acid is colorless, phenolphthalein is also colorless. So if you add both of them also, there you will not observe any change in color. That means it remains colorless. Okay, now it remains colorless. Okay, remains colorless. Whereas base plus phenolphthalein, it turns pink. Base plus phenolphthalein, it turns pink. Okay, if any substance turned to pink color, if you observe pink coloration by the addition of phenolphthalein substance, then you can say that the substance which you have taken is basic in nature. Okay, so like that you have synthetic indicators, two types of synthetic indicators, and finally you have olfactory indicators. So what are olfactory indicators? Okay, olfactory indicators. Third type of indicators are what? Olfactory indicators. Okay, so what are olfactory indicators? Okay, the word olfactory stands for what? Sense of smell. You have olfactory nerves connecting from your nose to your brain, which gives you the sense of smell, isn't it? Smell, sense of smell will be there. Okay, so olfactory indicators are the type of substances which can be detected whether a given substance to you is acidic or basic based on the smell that is being observed by the observer. Okay, so if you take the example for olfactory indicators, the first and best example is onion extract. Okay, now, or onion strips. You can make onion strips. Okay, to indicate whether the given substance to you is acidic or basic. How you can do this? You just take onion, cut it into small pieces, and wrap it on a white colored cloth, cotton cloth, a fresh white colored cotton cloth. You take, wrap all the onion pieces in that white colored cloth. Okay, and keep that white colored cloth wrapped with onion pieces. Okay, now keep that overnight in a deep freezer. Okay, now overnight you keep it in a deep freezer. Then next day morning, if you observe, the whole fridge, isn't it, the whole refrigerator keeps stinking, isn't it? Yes, a bad smell keeps coming out from what we call onion pieces. Okay, now onion what we call onion pieces. Okay, so if you take that cloth, you throw that onion pieces, take the cloth, make it into small strips, cut them into small strips, and test that onion strips with acid as well as base. Okay, so onion strips is having lot much smell. Okay, because we have deep freezed them overnight, lot much smell will come. Okay, so now how you are going to test onion strip plus acidic substance if you add. Okay, then if the smell increases for acid substances, the smell increases more. Okay, more suffocating smell you will be getting. That means with acids the smell increases more. Okay, now smell increases. Please remember this point. Smell increases. Same like that, this onion strip, if you take and if you add a basic substance to it, base, then the smell totally destroys. Okay, that is That is the way you can identify whether the given substance to you is acidic or basic. Okay, now smell totally destroys with base. Okay, now smell destroys. Okay, so in that way olfactory indicators can be useful by detecting what? Acid and base with the help of smell. Okay, same like that you have other examples are what? Vanilla extract or vanilla essence. Okay, vanilla essence, you have idea about this. Very good, best flavor it will give for ice creams and all. Okay, vanilla essence. And you have clove oil. Okay, now cloves. Okay, so these are the best examples for what? Olfactory indicators. So these are also type of indicators. So we have discussed about what? 3 types of indicators now. Okay, and then now we will move on to the chemical properties exhibited by acids and bases. Okay. Yes, what are the different chemical properties exhibited by acids and bases? You might have learnt about these chemical properties also in your lower classes. Okay, so how metals, how acids react with metals and what kind of gas will be liberated. Okay, what happens if acids react with carbonate salts. Okay, what happens if acids react with bases. Okay, so all these are the general properties, chemical properties that are exhibited by acids and bases we are going to learn now. Okay, so I request all the children to please kindly write and practice. Until and unless you write and practice, you cannot remember anything. Okay, just theory, I will just listen to ma'am's class, it will be enough for me, please. Okay, the more you write, the best you will be getting it into memorized. Okay, so please write and practice. So let us move on to what? Chemical properties of acids and bases. Chemical properties of acids and bases. Okay, so let us learn about them. Okay, so chemical properties are being discussed in the form of activities in your textbook. Okay, so first let us learn about reaction of acids and bases with metals. Okay, first reaction of acids with metals, let us learn. Reaction of acids with metals. Okay, so metals like sodium, potassium, magnesium, all these are very highly reactive with acids, and they liberate which gas? Yes, hydrogen gas will be liberated. And you might have learnt about the test for hydrogen gas even in the previous lesson also. Like in chemical reactions also you have learnt. What is the test for hydrogen gas? Yes, burning splinter puts off with pop sound. Okay, so here it can be explained with an example or with an activity. Okay, like you can take zinc pieces in a test tube and add HCl. Okay, through thistle funnel, if you are adding HCl gas, HCl acid, okay, then it gives rise to what? ZnCl2 plus H2. Hydrogen gas will be liberated. Okay, same like that you can take any other metal as well. Okay, so hydrogen, suppose if you take aluminium is being added to HCl. Okay, so you will be getting what? AlCl3, aluminium chloride plus hydrogen. But please remember, here also you have to recall the reactivity series of metals. Okay, like you have highly reactive metals can give you highly reactive metals which are highly reactive than hydrogen can only replace this hydrogen from the acid. Okay, highly reactive metals. Okay, like which are more reactive than hydrogen. Hydrogen has to be replaced or hydrogen has to be displaced from acid. Means the metal which you are giving should be what? A highly reactive metal than hydrogen. Okay, like what? Highly reactive metals like potassium, sodium, magnesium, calcium, okay, aluminium, zinc, iron. These metals can replace hydrogen, these are highly reactive than hydrogen, can give hydrogen gas. These metals can give H2 gas. Okay, but if you take least reactive metals like gold, silver, platinum, okay, less reactive metals, if they are dropped in acids, okay, you will not find the liberation of hydrogen gas. Okay, like you can take less reactive metals, take this as a note point. Less reactive metals like what? Like copper, you can take Ag, silver, Au, okay, platinum, etc. cannot give hydrogen gas when dissolved in acids. Okay, cannot give hydrogen gas, cannot give H2 gas. Please remember this point. Okay, so Cu plus HCl, if you take, hydrogen gas may be liberated, but it's a very less amount of hydrogen gas can be liberated, because copper is very least reactive metal. Even platinum, gold, very less reactive metals. That's why we call them as what? Noble metals. They generally don't react. Okay, so they are called as what? Noble metals, right? So this point please remember. Okay, so generally they give hydrogen gas, and hydrogen gas can be tested as the burning splinter puts off with pop sound. If it happens like that, okay, then you can say that the gas liberated is what? Hydrogen gas. Okay, same like that, can you expect the reactivity of metals with bases? Let us learn about them. Reactivity of metals with bases. Reactivity of metals with bases. Is this possible? Reactivity of metals with bases. Is it possible? Actually speaking, hydrogen gas cannot be liberated with bases, but you have only exceptional cases are there. So you have to learn about them. Okay, generally H2 gas cannot be liberated with bases. Generally H2 gas cannot be liberated. Okay, please remember this point. Generally H2 gas cannot be liberated when metals are treated with bases. Okay, now when metals are treated with bases, hydrogen gas cannot be liberated. Treated with bases. But you have exceptional cases. Like you can take only this exceptional case, like where zinc can react with NaOH and forms sodium zincate, Na2ZnO2. Okay, and it can liberate hydrogen gas also. Zinc can react with sodium hydroxide. The only metal which reacts with only base, okay now, the only metal zinc reacts with only base NaOH, not with any other bases as well. Please understand the point and remember this point. Questions may be asked in such areas only, from such areas only, where you have to focus more. Okay, so it forms what? Sodium zincate. Okay, sodium zincate. And this sodium zincate is actually amphoteric in nature. Zinc oxide is amphoteric in nature. Same like that, you can even expect this with aluminium as well. Aluminium plus NaOH gives rise to NaAlO2, which is called as sodium aluminate, and you can observe the formation of hydrogen gas also. Sodium aluminate. So this sodium zincate and sodium aluminate, okay now, sodium zincate and sodium aluminate are what? Amphoteric in nature. You write that as a note point. Okay, generally Al2O3 and zinc oxide are what? Amphoteric in nature. Note. ZnO, zinc oxide, and Al2O3, aluminium oxide, are what? Amphoteric. What are amphoteric oxides? Amphoteric in nature. What is amphoteric? The word amphoteric stands for substances which are both acidic as well as basic. You call them as what? Amphoteric. Substances which are acidic as well as basic. Okay, which exhibits both acidic as well as basic properties. Acidic and basic properties are called as what? Amphoteric oxides. Okay, so zinc oxide and aluminum oxide are what? Amphoteric in nature. Okay, and those two metals can react with sodium hydroxide and can give hydrogen gas. The remaining all other metals, they cannot react with bases and they cannot give hydrogen gas except zinc and aluminum. Please remember this point. So this is about reactivity of metals with acids and bases. And then we'll move on to reactivity of acids with carbonates and bicarbonates. Okay, second property is what? Reaction of acids. Okay, acids with carbonates and bicarbonates. Carbonates and bicarbonates. So carbonate salts generally when they react with acids, they give carbon dioxide gas. Okay, now liberates which gas? CO2 gas is liberated. Please remember this point. This is very important. Okay, so here you can take the example like any acid, HCl I am taking, react with a carbonate salt, Na2CO3. I think you all know this is called as what? Washing soda. Na2CO3 is what? Washing soda. Okay, HCl reacts with Na2CO3 and forms the respective salt, and along with that you have standard products formed are what? H2O and CO2. Please remember. Okay, CO2 and H2O fixed. This salt and water and carbon dioxide are the fixed products which are formed whenever any acid reacts with any carbonate salt. Okay, here I took the example of washing soda, Na2CO3. You can take CaCO3, limestone. Okay, so second example you can take HCl plus CaCO3 gives rise to what? CaCl2 plus CO2 plus H2O. CaCl2. Okay, now CaCl2 plus CO2 plus H2O. Okay, so like this you have the standard products which you are going to get are what? CO2 and H2O, and the gas liberated is carbon dioxide. And you might have learnt about the test for carbon dioxide. Carbon dioxide turns lime water milky. Okay, so that is a test for carbon dioxide gas. Okay, if you take bicarbonates like HCl, if it reacts with NaHCO3, sodium hydrogen carbonate, sodium bicarbonate, which in other words you call it as what? Baking soda. Sodium hydrogen carbonate, which is called as what? Baking soda. So HCl reacts with baking soda and forms same like that, NaCl, H2O and CO2 gas. Carbon dioxide will be liberated. Okay, so generally what happens when acids react with acids reacts with carbonate salts? They give carbon dioxide gas. Okay, acids reacts with metal to give hydrogen gas. Please remember these points. Okay, carbon dioxide gas will be liberated. How can you say that the gas liberated is carbon dioxide only? You need to take lime water. Okay, calcium hydroxide, you call it as what? Lime water. Slaked lime. Okay, slaked lime. When reacts with carbon dioxide, it gives white precipitate of CaCO3. Okay, and water. Okay, if you send excess CO2 through this solution, CaCO3 plus H2O plus excess CO2 if you send, okay, then this white precipitate gets dissolved. White precipitate gets dissolved, and again you will be getting a clear solution of calcium bicarbonate. You will get CaHCO3. Okay, plus water. Okay, again you get back a clear solution. Here what you got? White precipitate you got. Whereas when excess CO2 is made to pass through that solution, that white precipitate gets dissolved and you will be getting a clear solution of calcium bicarbonate also you will get. Okay, so like this you will be testing whether the gas liberated is carbon dioxide or not. Okay, So like this you have a reactivity of acids with what? Carbonates and bicarbonates. Okay, next we will move on to the third type of reactivity, that is what? Third type of reactivity is about neutralization reactions. Acids and bases exhibit neutralization reactions. Okay, now what are neutralization reactions? Reactions in which acids and bases react with each other to form salt and water. And before you actually go for neutralization reactions, just make a note that all metallic oxides are basic. All metallic oxides are what? Basic in nature. I gave you exceptional cases except ZnO and Al2O3. These two are what? Amphoteric, which means what? They exhibit the properties of both acid as well as base. Please remember. And all non-metallic oxides, okay, all non-metallic oxides are acidic in nature. Okay, acidic. Like you can take the example of CO2. Carbon dioxide is acidic. Nitrogen dioxide, sulfur dioxide, phosphorus pentoxide, all these are acidic oxides. Okay, non-metallic oxides are acidic, metallic oxides are basic in nature. Okay, so please remember that point. And when you come to neutralization reactions, let us come back to neutralization reactions. Acid plus base gives rise to what? Salt plus water. Such kind of reactions are called as what? Neutralization reactions. You can take a example of acid. Acid best example is HCl and base best example is NaOH. Acid reacts with NaOH. HCl reacts with NaOH. It gives sodium chloride, common salt plus water. Okay, and along with that you will get 13.7 kilocalories of heat is also liberated along with the products. Please remember. That means what? Neutralization reaction is an exothermic reaction. Okay, so here you are taking what? Strong acid and strong base. Here HCl is strong acid, sodium hydroxide is strong base. The so formed salt is what? NaCl, which is neutral. Okay, now neutral salt. And along with that, how much amount of heat is released? Once you check, 13.7 kilocalories of heat is liberated. If you take any one to be the weak acid, like I am taking CH3COOH, vinegar. Okay, now CH3COOH, okay, vinegar or acetic acid, when reacts with strong base NaOH, it gives CH3COONA, which is called as what? Sodium acetate. Okay, now sodium acetate plus water, salt plus water. Okay, so here also some amount of heat is released, but here you are observing 13.4 kilocalories of heat only is released. Okay, which means what? Here if you take if you take both strong, both acid and base both are strong, the heat liberated is 13.7. But here you took weak acid. Okay, now acid is weak, base is strong. Okay, if acid is weak, base is strong, the so formed salt is basic salt. Okay, now basic salt is formed, and here 13.4 kilocalories only is liberated, and the remaining, the difference amount of 0.3 kilocalories of heat is used up in ionizing this weak acid. Okay, now it is used up in ionizing that weak acid. Okay, so like this you have an example for what? Neutralization reactions. Okay, neutralization can be done even in between metallic oxides and non-metallic oxides also. Okay, metallic oxides when react with water, okay, you will be getting non-metallic oxides when react with water, you will get acids. Metallic oxides, when react with water, you will get bases. That is also treated as neutralization reaction only. Okay. So example we'll take. Listen, please listen carefully. Metallic oxide plus water. Okay, this is also treated as what? Neutralization reaction only. Metallic oxide plus water gives rise to what? Bases. Okay. Metallic oxides, when react with water, it gives bases. Okay. Like you can take the example of MgO. When reacts with H2O, it forms MgOH taken twice. Okay. Balancing I am not doing. It gives rise to base. Okay. Please remember. This is metallic oxide, basic in nature. Okay. Or even if you treat this metallic oxide, when reacts with HCl, then also you will get salt and water. MgCl2 plus H2O. So this can be treated as what? Neutralization reaction. Neutralization reaction. Okay, where acid and base react with each other to form salt and water. Same like that you can even take non-metallic oxides. Okay, non-metallic oxide when react with water. Non-metallic oxide plus water, it gives rise to acids. Okay, like you can take the example of sulfur dioxide when react with water. I'll take sulfur trioxide when react with water, it gives H2SO4, sulfuric acid. That sulfuric acid when made to react with NaOH, okay, you can get salt and water. That you call it as what? Neutralization reaction. Okay. Okay, please remember these all points. And I already told you like certain acids. Generally all acids will have what is there in common. What is common for all acids? H plus ion is common. In most of the acids, H plus ion is there. Okay. So all acids will have H plus ions. Okay. That means what? Whenever they are made to dissolve in water, H plus ions are released. Okay, so how can you say? Okay, conduction of electricity, current conduction of electricity by acids and bases, and even by salts also. Okay, conduction of electricity by acids and bases. You can understand the conductivity of current. Current conduction is done by acids or not. You can say that by performing the process of electrolysis. Okay, so electrolysis process you all have a idea. You will be taking a beaker or a volumetric flask you will take. Okay, in that you will be taking one electrolyte. What is electrolyte? The substance which allows electricity to pass through it. You call it as electrolyte. That electrolyte can be an acidic substance or a basic solution or even a salt solution. Acids, bases and salts all together they can be treated as what? Electrolytes. That means they can allow electricity to pass through them. That can be observed with the help of this small activity of electrolysis. So when you perform electrolysis process, you will take two metal plates. One is cathode and another is anode. Okay, which are connected to the terminals of a battery. Okay, so like this you will be connecting, and here you will be connecting one bulb also, so that you can even identify whether the substance which is taken inside the beaker can act as electrolyte or not. Okay, this is electrolytic substance or electrolyte. Okay, so the terminal which is connected to the positive terminal of battery, you call it as anode, and the one which is connected to the negative terminal of the battery, you call it as cathode. So these two metal plates will serve as what? Electrodes. Okay, and here if this electrolytic substance, if you take, is an acid, okay, check whether bulb is glowing or not. Yes, bulb glows. Okay, with acids bulb glows very strongly. Bulbs glow or bulb glows. Okay, even with bases also bulb glows. So bases, acids are what? Good kind of electrolytes. With bases also bulb will glow. Okay, and even with the salt solutions also. aqueous bases. AQ means what? Bases mixed with water. You call them as what? Electrolytes. They act as what? Electrolytes. Even for salt solution also bulb will glow, which shows that when electricity is made to pass through them, the particular substances which are taken as electrolytes splits into their ions. Okay, like if you take acidic substances, okay, if you take acids, okay, as an electrolyte, if you take HCl, on electrolysis it splits into H plus and Cl minus ions. Same like that, if you take H2SO4, on electrolysis it splits into 2H plus and SO4 2 minus ions. Okay, so acids are best electrolytes. Acids are electrolytes. You can treat them as electrolytes. Okay, that means they allow electricity to pass through them. Okay, if you take some basic substances, they also divide into their respective ions. Okay, like you can take NaOH. NaOH splits into Na plus plus OH minus ions. Okay, so splitting is happening even with bases also. Mostly you will be taking what? Aqueous basic solutions. Okay, like even if you take MgOH taken twice as electrolyte, it splits into Mg2 plus plus 2OH minus ions. So bases are also called as what? Electrolytes only. So they can allow electricity to pass through them. Okay, and even if you take salt solutions like NaCl, if you take, that also splits into its respective ions. Okay, Na plus and Cl minus. Same like that, CaCl2, calcium chloride, if you take, it gets dissociated into Ca2 plus plus 2 Cl minus ions. So on passing electricity, if you are observing the particular substance is allowing electricity to pass through them or not. So accordingly you are going to decide that particular substance which you have taken is electrolyte or not. So bases are good electrolytes, and even salts are also good electrolytes only, best electrolytes. Salts, okay, now salts are also good electrolytes. Okay, then what are non-electrolytes? Is there any substance which does not allow electricity to pass through them? What are non-electrolytes? Okay, so there are certain substances like glucose solution, fructose or sugar solution. Okay, they does not split into their ions. Such kind of substances are called as what? Non-electrolytes. Okay, non-electrolytes. Non-electrolytes. What are non-electrolytes? Which does not allow electricity to pass through them. Substances which does not allow. Okay, substances which does not allow electricity to pass through them. Okay, such kind of substances are called as what? Non-electrolytes. Okay, examples for non-electrolytes are what? Glucose solution, glucose, sucrose, sugar, starch. Okay, kerosene. Okay, kerosene. Such kind of substances are treated as what? Non-electrolytes. Okay, they does not allow electricity to pass through them, and you can observe the bulb will not glow. In the activity of electrolysis, bulb will not glow. That means acids, bases and salts are treated as what? Best electrolytes. Okay, and next, finally we have one more activity is there. Okay, which tells you that only what we call only aqueous solutions of acids and bases can turn, suppose if they are acids, only aqueous solution of HCl or H2SO4 can only turn blue litmus to red. Okay, dry HCl and dry H2SO4, dry acids which don't have H plus ions with them, which don't have water molecules with them, they cannot convert the color, they cannot change the color of the litmus paper. Please understand me carefully. Okay, note, dry HCl cannot change the color of litmus paper. cannot change the color of blue litmus to red. Blue litmus paper cannot be changed to red. That means what? Acids which are having water molecules with them, they only can change the color of litmus paper. Why it is like that? Because water molecules consist of what? H plus and OH minus ions, and water molecules gives mobility to that ions. Ions has to move. Okay, if ions are not there, okay, then mobility will not happen and color change will not happen. Okay, so that can be observed by the liberation of dry HCl with the activity of HCl and Na2SO4. When made to react with each other, you will be getting HCl gas. But a dry HCl gas cannot change the color of dry litmus paper. If you take wet litmus paper and if you test that, then because of the water molecules, because of the presence of water molecules which are present in them, okay, color of the litmus paper can be changed. That means wet litmus paper only can change the color. That means water molecules plays a very important role with the mobility of ions. Please understand the point carefully. Okay, so accordingly color changes can be observed. Okay, so this is also a very important note point which you have to remember. Okay, dear children, and you all have learned that about electricity. And one more note point I would like to give for you. Distilled water does not conduct electricity. Okay, distilled water does not conduct electricity because does not conduct electricity. Why it is like that? Because distilled water does not have ions in them. Okay, now because it does not have ions. Okay, now H plus and OH minus ions cannot be produced in that distilled water. Okay, it does not have ions in that. That's why distilled water cannot conduct electricity. If ions are there, ions will be moving from one place to another place, which results in the current conduction. But whereas distilled water does not have any ions, whereas rainwater can conduct very well. Okay, now rainwater can conduct electricity because rainwater consists of certain oxides, like rainwater conducts electricity. Please remember this point. Okay, rainwater conducts electricity. Okay, why? Because it has oxides, like because it has certain oxides like CO2. Okay, oxides like what? CO2, NO2, okay, SO2, etc. Such kind of oxides are making them into to liberate H plus ions when dissolved in water, when electricity is made to pass through them. Okay, so rainwater can conduct electricity, whereas distilled water cannot conduct electricity. Okay, so up to here we have learned certain important properties of acids and bases. Okay, in the next coming video we will be learning about what? Yes, strength of acids and bases, that is about pH, and also about salts. Okay, now different types of salts that are being obtained from by the process of electrolysis of brine solution. Okay, so until then I request all of you to please write and practice, make notes of what all your teacher says. Okay, I always say your hard work is your superpower. Thanks for watching. Bye.